Okay, so we're going to do some examples. When I draw the circuit up and tell you what we're going to do, I encourage you to pause the video and try to work it on your own, and then come back to the video as you need to deal with any questions you might have. That's 5 amps, 4 ohms, 10 ohms, 2 amps, 3 ohms, and 10 volts. And we are going to solve for this voltage here, Vx. So we're going to find Vx, and then solve for power. So we'll solve for the power delivered by each source and absorbed by each resistor. Okay. Okay. So, again, pause the video here and try to do this on your own. All right, so I'm going to label some mesh current variables. Here's one, I1. Here's another one, I2. And here's the third one, I3. So all clockwise. All right, there are 2 current sources in the circuit. Now, what's different than some of the problems we've worked is that we have one on the outside of a mesh, and then we have one shared between 2 meshes, which we haven't done before. But we're going to follow the same rules as we always have. Okay, so let's start by writing down the things that we know. Okay, so the 5 amp source on the outside of a mesh, I3 flows in this direction, so I3 is going to be -5. Okay, now I2 is shared between 2 meshes, so instead of having a known quantity relative to this, this current source, we're going to have a relationship. So I1 flows in the direction of the 2 amp source, I2 flows against, so we're going to have I1 minus I2 is equal to 2 amps. Okay, and I am going to hold on a second, I've lost Vx. Okay, so I'm going to put Vx in blue just so we can see it a little bit easier. Remember that we can write down what Vx is right now, and then we don't have to worry about it using Vx in anything for the rest of the analysis. So Vx is equal to, we're writing an Ohm's law equation, okay? So passive sign convention for Ohm's law has to hold. So Vx is equal to 4 times the net current that flows from plus to minus. That's what we need. So that's going to be I3 minus I2. Okay, so now we don't have to worry about Vx anymore. As a matter of fact, I'm going to change Vx at this point from this blue to, I'm going to make it a very light color, so we're not going to be tempted to try to use it. So I'm going to do this grayish color. Okay, so we don't worry about Vx. We don't need Vx to solve for the mesh currents now. We only need it at the end, and we have written down the relationship. Okay, so let's start with the mesh currents. Now, because we have this current source shared between 2 meshes, we are going to have to write both mesh 1 and mesh 2. Okay, we don't have to write a mesh 3 equation because we know what the mesh current is. It's that I3 is equal to -5. But we don't have an equation for that tells us what 2 is equal to, only this relationship. So we're going to have to write both mesh 1 and mesh 2 equations. Okay, so mesh 1. We'll start with that 10 volt source, moving from minus to plus. I'll add 10. Coming around to 3 ohm resistor, remember the rule, I'm going to subtract 3 times I1. Coming around to the current source, remember our hierarchy. There's not a voltage source there, there's not a resistor there, so our only option is to label the voltage and give it a polarity. And I'm going to call it Vs with this polarity. I chose this polarity because I want to solve ultimately for power delivered, so I'm going to label it so the current's flowing from minus to plus. You do not have to do this, okay? You could certainly do it the other way. So to finish this, moving from minus to plus, I will add Vs. I'm back to where I started. I can sum to 0. Okay, so when we have a current source shared between two meshes, we're going to have to label a voltage and it's going to enter into our equations. Mesh 2. I'm going to start with that current source. Now I'm moving from plus to minus through that source, moving in this direction. So I'm going to subtract that voltage. Minus Vs. Coming around to the 10 ohm resistor, I'll subtract 10 times I2. 10 ohm resistor is on the outside of a mesh, only sees that one current. Coming around to the 4 ohm resistor, forget about Vx. I'm writing the technique. I'm going to subtract 4 times I2 minus I3. And that sums to 0. Mesh 3, I don't need right now because I already know what the mesh current is. Now I know I'm going to need it because I have to solve for power for that source later. All right, so let's simplify these equations down a little bit. So I'm going to have minus 3I1 plus Vs is equal to minus 10. This equation here, the second, so this is mesh 1. The mesh 2 equation is going to be minus 14 I2 plus 4 I3 minus Vs is equal to 0. Okay. We know that I3 is equal to minus 5, so we will substitute this in here. Okay, and so now mesh 3 will simplify to minus 14 I2 minus Vs is equal to 20. All right, so we have these two equations here, simplified, but we have 1, 2, 3 unknowns. But our third equation is sitting right here. Okay, now if you don't like dealing with 3 equations, 3 unknowns, this is what I would do. I would add mesh 1 and mesh 2 together. Okay, and so what I'll get is minus 3I1 plus Vs minus 14 times I2 minus Vs is equal to, and let me rewrite this so it's down so I can fit it all in. So minus 3I1 plus Vs minus 14I2 minus Vs is equal to minus 10 plus 20. So when I add the two equations together, I add everything on the left-hand side and set it equal to the sum of everything on the right-hand side. And now these Vs terms are going to cancel out. And so I'm left with minus 3I1 minus 14I2 is equal to 10. And I'll use that with my I1 minus I2 is equal to 2 from what we wrote down at the beginning, what we knew. And now I have 2 equations, 2 unknowns. And I can solve for these. And I will get that I1 is equal to 1.06 amps. I2 is equal to minus 0.94 amps. Okay, now I need to solve for Vx. Again, Vx is equal to 4 times I3 minus I2, so this equation here. Okay, and when we substitute in everything, where is that? That's minus 16.24 volts. Okay, we can also solve for Vs. We're going to need it eventually to solve for power. So we can plug, we can use either one of these equations here with Vs in them to solve for Vs. So I'm going to use one of those. It doesn't matter which one you do. But when you do, you'll get that Vs is equal to minus 6.82 volts. Okay, so we've solved for the mesh currents. We went back and solved for Vs because we're not going to need that. We've solved for Vx. So now what we need to do is we're eventually going to have to write that mesh 3 equation because we're going to need to know the voltage drop across the 5 amp source. So I'm going to grab this circuit since we're going to use it for power anyway. Let's try that again. Let's bring it down here. Okay, so let's write the mesh 2 equation, or mesh 3 equation. Okay, so again, we forget about Vx. We only care about the technique here. So I'm going to subtract 4 times I3 minus I2. I'm going to come around to that 5 amp source. I'm going to need a variable across that source. Remember, it's not a voltage source. It's not a resistor. So my only option is to label a variable and give it a polarity. So I'm going to label that variable VT with that polarity such that the current's flowing from minus to plus, because that's what I need to solve for power delivered. So my equation now is going to be, I'm going to subtract VT because I'm moving from plus to minus. And that sums to 0. I know what I3 and I2 are, so I can solve for VT, and I'll get that VT is equal to 16.24 volts. Okay, notice here that VT and Vx are the same voltage, except I have reversed the polarity. Okay, so since I had to solve for Vx as part of the circuit, I didn't actually have to find VT because these two elements are in parallel, right? But I reversed the polarity to provide that voltage to get that power delivered. Okay, so if you recognize that, you could have saved yourself a step. If you didn't recognize it, you wrote the equation again, and it doesn't hurt to see that I've solved for Vx and solved for the VT correctly. Okay, at least they are the same. They're just opposite in polarity, so they have an opposite sign. Okay, all right, so let's solve for power now. So let's do the sources. We're going to use V as, P is equal to V times I. So the 10 volt source, P is equal to V times I. V is the value of the voltage source. I is I1. I1 flows from minus to plus through the source. So we're going to solve for power delivered when we use I1. So this power is equal to 10.60 watts. And this is delivered power. Let's go to the 2 amp source. P is equal to the voltage, which is Vs, the variable we labeled, multiplied by the value of the source, 2. So the 2 amp source power is equal to minus 13.64 watts delivered. So in this case, this source is actually absorbing power. All right, and then we have the 5 amp source. P is equal to V times I. This is VT, the voltage that we labeled across the 5 amp source, times the value of the source 5. And this is going to be 81.20 watts delivered. Okay, so the sum here is going to be 78.16 watts. So let's move on to power associated with the resistors. And I typically use I squared R when I'm doing mesh analysis. So let's start with the 3 ohm resistor. So the 3 ohm resistor is on the outside of a mesh, only sees mesh current I1. Okay, so P is equal to I1 squared times 3. And that is equal to 3.37. And it's absorbed because resistors only absorb power. Moving on to the 10 ohm resistor, P is equal to V times or I squared R. The 10 ohm resistor is on the outside of a mesh, so it only sees mesh current I2. So we'll use I2 squared times 10. And when we substitute I2 in, we'll get this is equal to 8.84 watts absorbed. And the last resistor is the 4 ohm resistor, okay? And we have Vx, so we could use that in our power equation, but I prefer to continue, just in case I've made a mistake. Maybe I solved for Vx incorrectly, maybe I wrote the equation down wrong, but I wrote the technique, I did the technique right. And so my mesh equations could be correct, but Vx I might have made a mistake on, okay? So I'd rather stick with the mesh currents. So I'm going to label this current here, the 4 ohm resistor. I can use I2 minus I3, okay? Doesn't matter which one I do. I can do I2 minus I3 or I3 minus I2 because I'm going to square it, so it doesn't matter which one I use. Times 4. And I'm going to get this is equal to 65.93 watts. And of course it's absorbed because resistors can only absorb power. And when I sum these together, I'll get that the sum of the power absorbed is equal to 78.14 watts. So these are pretty close, which makes me very happy because my answers are probably correct. Now, is it possible that you can get power delivered to equal power absorbed and still have the wrong answers? Absolutely. It's always a possibility, but since I have confirmed some other things like VT and VX, I feel pretty comfortable about this. All right, let's do another example. Let's see what happens when we have a dependent source in the circuit. I'm going to move to a new page. Okay. So we are going to find Vx and the power delivered by the 2Vx current source. So again, pause the video here, give give this a try and then come back. So we have a voltage controlled current source in this circuit. So this 2Vx voltage source provides 2Vx amps to the circuit, but it's controlled by the voltage drop Vx across the 5 ohm resistor with that polarity. Okay, so let's start with some mesh currents. So here is I1, here is I2, and here is I3. All right, so let's start by writing down what we know, and we've got a lot to know about in this particular circuit because we've added a dependent source, which creates a whole nother level of things that we need to, relationships we need to write down. So we know we've got a current source, an independent current source here shared between mesh currents I2 and I3, so we can write that one down. So I2 minus I3 is equal to 2. So the I2 flows in the direction of the source, I3 flows against. We have the 2Vx source, okay? 2Vx is on the outside of a mesh. It sees mesh current I2, but it's flowing in the opposite direction. So we're going to say that I2 is equal to minus 2Vx. Okay, so those are the two current sources. Now, in mesh analysis, almost always when we have a controlling element like we do here, Vx, we can write that controlling element in terms of the mesh current variables. So we have Vx here. It's a voltage drop across the 5 ohm resistor that is shared between two meshes. So we need the net current that flows in this direction. We're writing Ohm's law. Okay, we're not writing a KVL equation, we're writing Ohm's law here. So we need the current flowing in this direction. That's going to be I1 minus I2. Okay, so Vx is equal to the resistance 5 times the net current I1 minus I2. Okay, so now let's think about what we need. Okay, so we have one equation here. All right, let's substitute Vx into this expression while we're here before we get moving on this. So we're going to have I2 is equal to minus 2 times 5 times I1 minus I2. So I've just substituted Vx into that expression. And so now I've got I2 is equal to minus 10 I1 plus 10 I2, or 10 I1 is equal to 9 I2, or I1 is equal to 0.9 I2. Okay, so we have this equation now. So we know what I1 is in terms of I2. We have this other relationship here, I2 is equal to, or I2 minus I3 is equal to 2. So let's write our mesh 1 equation, okay? We may find that we don't need any other equations after this, okay? So mesh 1, we don't have another relationship for I1 right now. So let's write the mesh 1 equation. So starting with that 6 ohm resistor, I know I'm going to subtract the voltage. It's 6 times I1. 6 ohms is on the outside of a mesh, plus 10. Okay, minus, forget about Vx, minus 5 times I1 minus I2. Writing the technique, I know I'm going to subtract the voltage. It's going to be the mesh I'm dealing with minus the current on the other side. Back to where I started, I can sum to 0. So now I have a relationship between just I1 and I2, and I can use that to find I have this other equation here, so I have two equations, two unknowns in terms of I1 and I2. Okay, so while I didn't know I3 or I2, knowing I2 is equal to, knowing that I2 is equal to this, even though it's a variable, it's not a firm number, and that I have this other relationship here, I'm really done as far as mesh analysis goes for solving the mesh current variables here. Okay, so I'm going to stop here for a second and I'm going to do some simplifying and some solving. Okay, so I've got minus 11 I1 plus 5 I2 is equal to minus 10. Okay? So between this equation and this equation, I can now solve for I1 and I2. So I'll do that. I1 is equal to 1.84 amps. I2 is equal to 2.04 amps. And now that I know I2, I can solve for I3 using that equation. So I3 is equal to, where's I3? I3 is equal to 0.04, so very small. All right, so I can also solve for Vx here. That's one of the things we were asked to solve for. So I can use this expression here to solve for Vx. So Vx is equal to 5 times I1 minus I2, and Vx is going to be minus 1.02 volts. So now I have all of my voltages and all of my currents that I need, all my mesh currents and my voltage that I needed to solve for. Now I need to solve for the power delivered by the 2Vx source. So I'm going to grab this circuit again and pull it down so we can see it. Okay, so we need to find the voltage drop across that 2Vx source in order to find the power delivered. So we're going to write the mesh 2 equation. Okay, so our mesh 2 equation, I'm going to start with that 5 ohm resistor. I don't care about Vx here. So I know I'm going to subtract the voltage, which is going to be 5 times I2 minus I1. Coming around to the current source, I don't know what the voltage is. It's not a voltage source. It's not a resistor. Just because Vx is in the expression for that source has nothing to do with the voltage drop across it. This is a current source. I have to label a variable and give it a polarity. So I'm going to label it with this variable and this polarity such that it appears to be delivering power, because that's what I've been asked to solve for. You could certainly reverse the polarity and just deal with it when you solve for power as well. All right, so this is minus Vs2 because I'm moving from plus to minus. Okay, then coming around to the current source, I can't finish this off without giving a variable across that current source as well. So I'm going to call this, put it in red, I need to label this one as well, and I'm going to call it Vs1. Right, did I do that? No, I did that backwards. Okay, so this is Vs1, that's Vs2, that's correct. Okay, so moving from minus to plus, I'll add Vs1, and that sums to 0. Okay, and so now, because I have 2 variables here, Vs1 and Vs2, I'm going to need that mesh 3 equation. Okay, so I thought I might just be able to get away with this with just the one mesh equation, mesh 2, but I'm going to have to do mesh 3 as well because of this current source shared between the 2 meshes. So I'll write the mesh 3 equation too. So mesh 3, starting with the current source, moving from plus to minus, I'll subtract Vs1. Coming around to the 1 ohm resistor, it's on the outside of a mesh, so it's going to be minus 1 times I3. I know what I3 is, so I can solve for Vs1 immediately. So Vs1 is equal to minus 0.04 volts. Okay, and now I can substitute Vs1, I1, and I2 into that expression and solve for Vs2. I'll get that Vs2 is equal to minus 1.06 volts. So let's solve for power associated with that 2Vx source. Okay, so power is equal to volts times amps. The voltage is Vs2. The current is 2 times Vx. Okay, so this is amps. That is volts. So don't let the variable in the expression for the dependent source throw you. 2Vx has units of amps. Sometimes it might help you to remind yourself of the units by putting those in parentheses next to the source, like I did up here. All right, so I'm going to substitute in. So this is minus 1.06 times 2 times Vx, which I have solved for, which is minus 1.02 times 2 there. And so this power is equal to 2.16 watts delivered. Okay, so the voltage Vx was negative, the voltage Vs2 was negative, so I ended up with positive watts delivered. Okay, I encourage you to stick with this problem and try to solve for the power delivered and absorbed by every element and make sure those sum up together. It'll give you some good practice. Let's do another example. Is that our first? No, our second. Okay. Let's do another example. You know what? Just give me a second. I'm going to redraw this. This is turning out horribly. Okay, let's try this again. Okay, so we're going to find Ix and V0 using mesh analysis. All right, so let's get started. I encourage you again, pause the video and come back to it after you've attempted this. All right, so mesh currents. I'm going to put I1 here, I2 here, and I3 here. Okay. It does not matter which way you order these two. It doesn't matter if the top one is I1. Okay, so there's nothing specifically correct about the order that I'm going in. Okay, so let's start with what we know. So I3 is equal to 4 times Ix. The 7 amp source shared between two meshes. So I2 flows in the direction of the source, I1 flows against. So we'll have that I2 minus I1 is equal to 7. Okay, we'll also have Ix, which is the current that controls the current controlled voltage source. So we have this current controlled voltage source here. Ix controls it. Ix is the current flowing in this direction. So that is based on I1 minus I3. All right, so let's start with some mesh currents here. So, or mesh equations here. So mesh 1. We don't know I2 or I1, so we're going to have to write both of those equations here, which means we're going to have to label a voltage drop across that 7 amp source. I know that's going to happen. I'm going to go ahead and label it now. I'm going to label it and call it, what are we going to call it? Well, if I label it with this polarity, it's just V out, isn't it? This V0 here. Okay, so I'm just going to call that V0 as well. That way we're not adding an extra variable. All right, simple enough. So mesh 1, we have minus 20. Forget about IX. We don't worry about that now. Minus 20 minus 10 times I1 minus I2. Excuse me, I3. I1 minus I3. I3 flows on the other side of the 10 ohm resistor, not I2. Coming around to the 7 amp source, and do minus V out, V0. I call that V out when I'm teaching EE315 because it's usually the output voltage. So I often say when I see VO or V0, I say V out. Just in case I slip up and say that. All right, mesh 2. So we're going to have plus VO coming around to the resistor. Forget about VO across the resistor. It's going to be minus 40 times I2. The 40 ohm resistor is on the outside of a mesh. Okay, so that's pretty simple. So let's look and see what we have here. Okay, so we have the following equations. We don't need a mesh 3 equation because we've already written down what it is. So mesh 3 we don't need. Okay, even though we don't know what 4ix is, it's a single value. We're not relating two mesh currents to 4ix. All right, so I'm going to substitute ix into this equation. So I'll have I3 is equal to 4 times I1 minus I3. Or if I simplify this equation down, I'll have minus 4I1 plus 5I3 is equal to 0. Okay, so there's one equation. I also have the equation here for the 7 amp source. So I've got minus I1 plus I2 is equal to 7. So that's another equation. Okay, and so now if I look at these two equations here and I sum them together, I'll get rid of V0, okay, or VO, all right, and I'll have an equation in terms of I1, I2, and I3. So let's do that. Let's simplify, let's add these together and then simplify. So when I add them together, I'm going to have, so add mesh 1 and mesh 2, and I will have minus 20 minus 10 times I1 minus I3. The VOs are going to cancel out. So minus 40 I2 is equal to 0. All right. So when I simplify this down, I'll have minus 10 I1 minus 40 I2 plus 10 I3 is equal to 20. Okay, so I have 1, 2, 3 equations, 3 unknowns, and I can solve. Okay, so I'll have that I1 is equal to hold on just one second. Please hold for just a second. I'm going to pause. Okay, I'm back. I needed to check an answer here, so I paused for a second. So I1 is equal to minus 7.14 amps. I2 is equal to minus 0.143 amps. And I3 is equal to minus 5.71 amps. Okay, so those are our three currents. We needed to solve for Ix and V0 or VO. So Ix is equal to, what did we say? Ix is equal to I1 minus I3. So that's minus 1.43 amps. And then we had to solve for VO. VO we can get from that mesh 2 equation right here. So VO is equal to 40 times I2. And that's equal to minus 5.72 volts. Okay, so again, I encourage you to solve for power delivered by each source and absorbed by each resistor. Okay, I'm going to do one more example problem. Moving to a new page. Okay, and this is the current Ix that controls this current controlled voltage source, 3Ix. Okay, and we're going to find Ix using mesh analysis. All right, so, and let's find, while we're here, let's find the power delivered by the 3Ix voltage source. Okay, so let's label some mesh currents. I'm going to call this one I1, this one I2, and this one I3. All right, let's start by writing down things that we know. We have a dependent source in the circuit. We have a current source in the circuit, so we're going to know some things. So for the 4 amp source, I2 minus I3 is equal to 4. Okay, I2 flows in the direction of 4 amps, I3 flows against. All right, there's nothing that we can write as far as this is concerned, the actual value of the dependent source, but we can write the relationship between Ix and the mesh currents. Okay, and so Ix is equal to the current that flows in the direction of Ix, which is going to be I1, minus the current that flows against I2. Okay, so there are the things that we know. All right, let's write some mesh equations. I'm going to see if I can keep these here. Maybe I can get one or two of them in here. We're going to end up having to write all three mesh equations because we don't know anything about a single mesh current here. We only know the relationship between I2 and I3, for example. So we're going to start with the mesh 1 equation. So our mesh 1 equation, starting with the 5-volt source, we're going to have 5 minus 2 times I1 plus 3 times IX minus 10 times I1 minus I2. And that sums to 0. And don't worry about IX. Remember, we've already written down the relationship as far as that writing the mesh equation through that 10 ohm resistor. All right, the mesh 2 equation. We'll start with that 1 ohm resistor, and I'm going to subtract, 5. All right, so starting the mesh 2 equation, starting with the 1 ohm resistor, I'm going to subtract 1 times I2, it's on the outside of the mesh, coming around minus 10 times I2 minus I1. Coming around to the current source, using the hierarchy, not a voltage source, not a resistor, I need to label a voltage variable and give it a direction, or a polarity, excuse me. I'm going to call that VS with that polarity, although you could certainly reverse that polarity if you wish. It does not matter. All right, so minus 10 times I2 minus I1 coming around to the source plus VS is equal to 0. Then mesh 3, starting with the 4 amp source, now I'm moving from plus to minus, I'll subtract VS. Coming up to the dependent source, I'll subtract 3IX. Coming around to the 4 ohm resistor, I'll subtract 4 times I3. And then coming around to that voltage source, moving from minus to plus, I'll add 8. Back to where I started, I can sum to 0. So I've got all of these equations now. And we'll have to maneuver through this and solve. Now, what I find is a lot of students at this point get a little bit scared, or they struggle a little bit at this point to see what to do next. I want to remind you that at this point, the circuits problem is over. You have written down all of the relationships. You could change all the X's and V's, or all the I's and V's to X's and Y's, and this would be a math problem. The circuits problem is over. It is now time for math. Okay, so don't make this harder than it needs to be. You guys know how to do algebra. So now just focus on the math. All right, so let's just go ahead and do that. Let's just simplify our equations down and see where we are. So I'm going to do a couple of things. I'm going to substitute IX into these equations as appropriate. Okay, and do some simplification. All right, so starting with mesh 1, I'm going to have 5 minus 2I1 plus 3 times I1 minus I2, doing that substitution, minus 10 times I1 minus I2 is equal to 0. So let's keep simplifying this. So I'm going to have minus 9 I1 minus 7, or plus 7 I2 is equal to minus 5. So there's our mesh 1 equation simplified. Let's go to mesh 2. So mesh 2 is going to be 10 times I1. I'm just going to do the simplification here. I don't have to do any substitution. So 10 times I1 minus 11 I2 plus VS is equal to 0. So there's mesh 2. And then mesh 3, I'll have minus VS minus 3 times I1 minus I2 minus 4I3 plus 8 is equal to 0. All right, and so I'll have minus 3I1 plus 3I2 minus 4I3 minus VS is equal to minus 8. So there's the third mesh equation all simplified. So now if we look at these for a second, I've got, just from the mesh equations, I have 3 equations and I have 1, 2, 3, 4 unknowns. So I need that one more unknown, and we have it. We're going to go back to our knowns and grab that I2 minus I3 is equal to 4. Okay, that's why I like starting with the knowns. Then I don't panic later that I don't have enough equations. So we're going to have I2 minus I3 is equal to 4. So now we have 4 equations, 4 unknowns. We can simplify this down a little bit. We weren't asked to solve for Vx. Remember, all we were asked to solve for Vs. We were asked to solve for I1 and the power through the 3ix source. So we don't need Vs. So let's go ahead and add mesh 2 and mesh 3 together. So let's add mesh 2 and mesh 3. And then we will get 7I1. I'm going to do the simplification at the same time. So 7I1 minus 8I2 minus 4I3 is equal to minus 8. Okay, so now that combined with my I2 minus I3 is equal to 4, and my mesh 1 minus 9I1 plus 7I2 is equal to minus 5. Now I have 3 equations, 3 unknowns. You could simplify this further, or you could go ahead and put this into your calculator and get the answers that you need. When you do get those answers, they should be that I1 is equal to 3.86 amps, I2 is equal to 4.25 amps, and I3 is equal to 0.25 amps. And so remember that we solved for Ix at the beginning. Ix is I1 minus I2. So Ix is equal to minus 0.39, excuse me, amps. Okay, so I added in at the end, let's solve for the power delivered by the dependent source. Okay, so this source here, we want to find the power delivered by it. Okay, so what we want is the current that flows in this direction, right? It's the current that flows from minus to plus. That's going to give us delivered power. So that's going to be I1 minus I3. Okay, so let's come back down here. So the power for the 3ix source is equal to the voltage, which is 3ix, even though there's a current in this voltage equation. Okay, the dependent source is based on a current. This has units of volts. And again, it might help you to put units next to these dependent sources to make sure that you don't get confused. Ix has nothing necessarily. You don't assume that Ix has anything to do with the current flowing through that source. So we have 3Ix multiplied by the current. We want the current that flows from minus to plus because we're solving for power delivered. So that's going to be I1 minus I3. Okay, so we have all of these. We can substitute them in and find this power. And since I added that at the end, I'm going to have to calculate it now. So it's 3 times that. So this is minus 1.17. This is 3.61. So this is minus 4.22 watts delivered. So this particular source is actually absorbing power. Now let's go back and just remind ourselves that we were solving for this net current, which is going to be I1 minus I3. And so we ended up, because Ix is negative, we ended up with negative watts delivered for that 3Ix source. Okay, so that's everything for mesh analysis examples. There practice problems you can work. Any problem that you've worked using nodal analysis, you can work using mesh analysis and vice versa. So you should have lots of problems to work. brute force, you can work using any problem. You can take any of these problems that we've worked here and practice doing a nodal analysis on them, and vice versa for mesh analysis. So the more you work, the more you complete the problem through all the way, including solving power every time, the more confident you're going to be, the better off you're going to be from a time management standpoint. Okay, so that's all.